Hello everyone. In this video, we are going to discuss about a problem in Newton's second law, that is with the work energy method. The problem goes like this. There is a weight of 80 Newton which is pulled up by a rough inclined plane which is 35-degree inclined to the horizontal surface. A force of 75 Newton is applied, and this force is at an angle 15 degree to the inclined plane. Now let us try how to solve this problem. To solve this problem, let us draw the free body diagram. Now this is the block. Now we have normal reaction which is up against the rough horizontal plane. Let me call it as N here. Then since the applied force is inclined, we can resolve this into two components. One is up the plane, okay, perpendicular to the plane. Okay, 75 cos 15 up the plane, then 75 sin 15 perpendicular to the plane. Weight of 80 Newton will make an angle 35 degree like this. Therefore, the weight is also resolved into two components. One is in this direction, another is in this direction. Okay. So this is 80 cos 30 and this is 80 sin 30. Okay. So this is the free body diagram. The weight is resolved into two components. One is perpendicular to the rough inclined plane. Second is along the plane. Then the applied force 75 Newton. The applied force 75 Newton is resolved into two components. Then you have then you have normal reaction which is perpendicular to this one. When you apply a force 75 Newton, this is the direction of motion. To oppose this, you have you have a frictional force. You will have a frictional force. Okay. Now after drawing the free body diagram, now let us apply the condition. The condition of equilibrium, sigma Fi equal to 0. So we have normal reaction N acts up, then another force 75 sin 40, another force 75 sin 15 acting up. Then you have third force, that is 80 cos 30 which is acting down, which is equal to 0. Upon solving, you will get N as 49.87. Next is we need to solve this by work energy method. So work energy method says that work done along the direction of motion is equal to change in kinetic energy. Work done is force into distance along the direction of motion. So work done is summation of the force along the direction of motion into distance travel. Okay. Now if you look at the picture, along the direction of motion, that is up the plane. So up the plane is taken as positive and down the plane is taken as negative. So solve this one, you have to take the net force along the plane. So this is minus, this is plus, and this is minus. These are the three forces: 75 cos 15, 80 sin 30 and F. These are the forces, out of which 75 cos 15 is positive and rest of the two are negative. The net force along the direction of motion is given here, that is 75 cos 15, 80 sin 35 and minus F into distance travel is equal to half m v2 square minus v1 square Initially, the object is or the system is under rest, therefore, this will become 0. This will become 0. The problem is solved by assuming two cases. Case 1, it is a smooth surface, which means coefficient of friction equal to 0, which in turn results in force of friction as 0. Force of friction as 0. Now the forces like 75 cos 15 becomes 74.44 and 80 sin 35 becomes like this, and force of friction, since mu is equal to 0, this term vanishes. Now this is multiplied by the distance travel, which is the part of the question. So upon solving we'll get V2 as 5.1 meter per second if the surface is smooth. If the surface is smooth. And second case, if we assume coefficient of friction is 0.23, which means I need to consider the force of friction as well. Now again the same data, except in the case 1 F equal to 0, here F becomes 0.23 into 49.81 because F is equal to mu n, which we are aware. Now substituting mu is equal to 0.23 and we have force of friction here. If force of friction is considered, then velocity is 3.847 meter per second. If the surface is taken as smooth, then we'll have final velocity as 5.1 meter per second. If it has some coefficient of friction, then final velocity will become V2 equal to 3.847 meter per second. Thank you.